Awesome. Good evening. My name, as introduced, is Evan Morikawa, and I work just down the road at a company called Nihilus, building an open source, extensible React-based email client called N1. But tonight I'm going to be talking a little bit about plugins with React, specifically about how React has really helped us think about our application in terms of these individual plugins, and then some of the challenges that imposed on us with the data models that we had to use. There's a lot of different data models out there, and hopefully one of the goals tonight is to sort of demystify them a little bit and talk about some of the trade-offs that we made in selecting some of them. So first of all, let me talk a little bit about plugins. And by plugins, I mean the types you're familiar with in Chrome extensions, or plugins in the Atom text editor, or even the WordPress plugins, and basically just ways to extend an application. This is very important for us building our email client because the core piece of what we wanted to do was to be able to build an email client that you could add these individual plugins into, that you could extend functionality to. The other reason it's worth talking about plugins here in a broader sense is that even if you're not building an application that's designed to support these, building for plugins is really the ultimate test of extensibility, of modularity, of making sure that you don't just go hard code a bunch of things in place, but really know how to move everything around and keep things dynamic. And that is by far one of the strongest pieces that React is good at. So I'm just going to start right in with just a little bit of a concrete example to get us thinking about this concept of plugins. So in our composer, right, we have some bar at the bottom, and you need to have a send button in there, maybe attach a file, trash or draft. And if in a traditional way of building an application, right, you would just hard code these in. These are the only things that you need to have going, so just write them in there. In a traditional model of plugins, like the way the Chrome extension system works, or even the way the Atom text editor worked, really the only thing you could do to extend this piece is something like this, right? This is a little bit of jQuery here, where you grab the button, you append your node. In the case of Gmail extensions, you kind of reach into the DOM and grab some auto-generated CSS class and hope for the best. Needless to say, this model of just jQuery appending stuff does not particularly play well with React. If you start adding stuff into the middle of your rendered React DOM, bad things happen. Things explode, and it's just not a great way, in addition to the very nature of that extension model, to make something extendable that supports plugins. So what can we do with this? Well, luckily, one of the best features about React is that we can treat components as data, as information, which means that I can take these three hard-coded buttons here and just move them out into their own array, at which point you can render them accordingly. This is React injecting each of its components one after another to let you render this, which means that if I somehow could magically add my plugin into this area, it too would be rendered in this sort of bar. This concept is pretty much the basis of a lot of the plugin view system that we have, and we took pretty much this exact code and wrapped it up into a component that we call this injected component set. Another nice thing about React is its contract around props. Right? I can say anything that's in this injected component set is going to get a draft as a prop. And furthermore, now I have a way to describe declaratively where things should go. So in this case, I want anything that wants to render itself specifically in the bottom bar of some composer register itself there. And as a result, we can use a basic action to say, I want to register my plugin in some little location bottom bar. But I can extend this further, because you might not want a hard code based on a location. I can, say, define it by role. Now, anything that needs to be some sort of send action, regardless of where we put these buttons, will get rendered into this injected component set. And I subsequently change the way that I register this component. And now I have this flexibility to move this injected component set around and still get anything that wants to render in there accordingly. This is a nice way to keep everything flexible, and while some things do need to be very specifically to some sidebar, Other pieces are much more role-based. And you can imagine other schemes to want to encode where you move stuff as well. One thing I want to mention about this register component is then this data side of it, right? Like I said, we can store React components as data, but where do we keep that data? How do we manage that data? The management of that data is sort of the focus of a lot of the remainder of this talk. In our case, we created a basic component store and backed it by a basic Flux implementation. When you call register component, that component will get saved in this store. This store is a singleton. It is globally accessible, which is how all the different parts of the app can find all the different components that we want to render everywhere. And subsequently, then our injected component sets all over the different page can listen to this store and grab just the data and information that it needs. This means that we can not only just add extra components to the bottom, but makes it a really extensible way to build an application that is built around a lot of components. To show you specifically what that means in terms of our app, this is N1. It is a email client that, as actually you will note, runs on the desktop as a native Windows, Mac, and Linux app, but is fully built in React. Another thing that powers this is a project from GitHub called Electron, which you might have heard of by now. But basically, at the end of the day, what it does is that it combines Chrome and Node.js into one rendering environment, which means everything you see here is built with React. I have all of the access to the DOM, but I have a native Node in here as well, which means we can kind of do cool things like back all of this with a local SQLite database and really pull all of these plugins from disk, from any sort of extra file source. But the point of showing this plugin system here is actually bringing up that bottom bar I showed you. By default, you'd imagine a stock email system. You'd want to send an email, right? Like add an attachment, trash it. But because everything can be dynamically injected at runtime, we can load a whole set of plugins to greatly extend the functionality of that one toolbar area, which means that by the time I continue to add on a bunch of these extra plugins, now instead of just being able to have that basic piece there, I can create templates that will combine plugins that will like drop in a template, or another one that can let me quickly schedule events and propose time to meets and integrate with the calendar, or other ones that will do link tracking and open tracking, can help me translate it on the fly and then send the whole email in about an hour or so. And all of those are dynamically runtime injected plugins that load through the same component injection system. And actually, we have the capacity here to show where all of those regions are. So everything in this app, from the list of email threads to the messages to the sidebar, are their own plugins. All those extra third-party ones you just saw are added in, but even the things that you would think of as core are also plugins in the system. And by doing plugins like this, it's much easier to keep track of the specific places that they exist. You don't have this jQuery soup of injecting on top of each other. It means I can have more than one extension loaded at the same time and not have the whole app crashing to a halt. This does come with a couple consequences, though. One is that now the data model gets increasingly complicated to handle, particularly because I have a lot of these plugins that are trusted, but nonetheless third-party plugins they're mutating the data all over the place. They all want to have access to these different types of data models, which brings me to the next major piece about this is thinking through how we deal with the data in the system. Now in the React world, we have a lot of options out there, and increasing so in a plethora of them. In the case of the component store, like I said, we started with a basic Flux implementation, because in this case it was a very discrete set of actions. But there are other places in the app, like for example, listing all of these different threads, talking to the database, where that model started to break down. And what I want to do is sort of, first of all, walk through some of these different frameworks, at least as we use them, and give a visual language for them. and finally sort of talk about some of the differences between the different systems that we have. So your basic Flux implementation that we use, in our case, has some external data source, right? Be it our cloud APIs, be it the database, be it the file system, and a bunch of components that we need to render. In the traditional Flux model, the way that this would work is you'd get some action that would come through, would broadcast an action over a dispatcher, and our store would be responsible for fetching data. Like, I want to grab these plugins from disk. It would return them asynchronously, keep it in the store, and the store would say, I've just changed. It would trigger to the world that something has need to be updated. And the components would then grab that data back into itself, and the whole cycle is complete. That's generally the process that backs a lot of these Flux models, that backs this component store that we have. And as a result, you can map something like this very similarly onto a Redux model as well. And once again, in this same example, we have our external asynchronous data source. In the Redux world, I would dispatch an action that would create these action creators, as sort of specified by the circle here. In classic Redux way, that action creator optimistically will send an action, reduce it, update my view, and asynchronously go and start fetching data from my data source. Action creator fetches it, gets some data back, dispatches yet another action that has my updated data, sends it through the central reducer, drops it into my React component. This model is really nice when you have a set of discrete actions that you want to do, be it registering a component, like clicking a particular button in your application. It has all the benefits of keeping everything functional and declarative that Redux and the whole library supports. In our case, we have, as I mentioned, the whole system is backed by a SQLite database, which means that this is sort of what we started to treat as our asynchronous data source for a lot of the information in our application. If we were to build this in a Redux-like system, the design would look something similar to the following, right? We would have some action creator, then in our case, like I want some email threads from a database. I'm actually firing SQL to a local SQLite instance here through a Redux action. That action creator goes and gets the data, and then dispatches that action. I can reduce it, get the threads I want, manipulate it however, and then that drops straight into my React component, my thread list. If I want a slightly different query, say I want a different set of threads, I want a different set of messages, once again, create an action creator, slightly different query, fetch the data, reduce it, drop it down to my components. Needless to say, one of the things that becomes problematic with this is every time I am getting new data over and over again explicitly, I'm constantly fetching for more things from all over the app. And in this one example, that's not that bad when the actions are discrete. But in our case, that database is changing all the time. All the different plugins might want to change the data. There's a lot of data coming in from WebSockets, from just user interaction in general. So there's a large number of changes that are constantly happening. And furthermore, there are a lot of different parts of the app that need to listen to different parts of the data. There's a thread list over here, there's a composer over here, a message list over here. And setting up all of the action creators to manage this and manually start fetching all of this data very quickly becomes very difficult to manage and reason about, even with this type of Redux model. So one of the things we found for this particular case was treating our database as just this constantly updating stream of asynchronous events, and declaratively wiring it straight to a component. And the model that we use to do this is through observables. Specifically, we use the RxJS library about this. But the observable pattern is basically around taking some constantly updating data source. In our case, a database, but it could also be a WebSocket as well. And you basically declare that I want anything that matches this query, no matter when it comes in, to just drop straight down into my component. And this works for the database, and as all of those events come in, you treat things as a pipeline as opposed to a set of individual actions. To show you this specifically in code, this is generally what it would look like. Rx is the library here. And I'm creating an observable that's defined declaratively by the query that I want, right? Select some threads where foo is bar. What this does under the hood is this says anytime anything matches that query comes in from whatever source, trigger this callback here that I've passed to my subscriber. In this case, I'm setting state to React component, but that could be to props, that could be to anything else here too. This is really powerful because I don't need to constantly be going back to this query. It gets set up once, and instead of resolving once, like a promise would, in a way, it's sort of resolving all the time. It's constantly triggering as this gets set up. The other nice thing about this, too, as opposed to setting up like a single callback source, is that I do this declaratively. I say I only want it to match this query, and that's just how the way to think about it. You think about it in terms of pipelines. The other extremely powerful way that this changes your thinking is because of the subsequent chaining you can do on top of that. One of the best things about the Rx library in particular is it has an extremely rich set of these chainable functions, so you can combine streams together, you can filter them, you can zip them, you can reduce them, which is not something you think of doing with with like a series of actions, but becomes very natural when you think about things as a pipeline. This works very well for all sorts of asynchronous data sources. Like I said, in our case, we use this database, but it works extremely well for constantly updating WebSocket connections. The Rx library, their tutorials talk about like in a constant stream of stock ticker updates and things like that. The other nice thing about when you think about it in terms of sort of just the straight pipeline is then that really helps fix a lot of the issues when we have a lot of different components that subscribe to lots of different types of data. It means that I can declare that this component maps to this query, that a component over here maps to just the set of messages. And now as I have this stream of data coming through, I let the observable systems take care of all of that, like filtering and mapping for me. And now my problem turns into really just a plumbing problem, as opposed to trying to manage a set of actions and when and where and how to dispatch them. This type of model has really worked well for some of the places that are backed by databases very intensively, like these thread lists here, the message list, our list of categories that we have as people add and remove labels. But one big thing I want to leave you with is that I'm very much not supposing or trying to convince you that observables are the next big thing. Because there are lots of other systems in our application where that just doesn't make a lot of sense. Specifically, going back to our component store, this thing that we use to manage plugins. That is a system that has a very finite set of very simple and discrete actions that need to update and change this. It is not a constantly updating asynchronous event stream. And as a result, it's useful to not necessarily see these different models as replacements for each other, but tailored to more specifically the type of problems that you encounter. And over time, after building this app, we tended to see that lots of different pieces of it have different needs for different data models. And like I said, putting that all together has finally helped us get to this point where we can support a lot of these different plugins, but there's definitely a lot of space to go as this ecosystem continues to change, as we discover new issues with it. I will note that the entire application is open source. If you go on to GitHub, you can find N1. We very much strongly believe in having everything here in open source. This is, we hope, a reference for React developers looking for these types of models, people building Electron apps. We actually were the benefits of Atom open sourcing their platform as well, which sort of brought us into this whole desktop-based world in the first place. And something that hopefully everyone can get inspiration from. I finally want to mention, of course, that myself, these two up here, plus a bunch of others, is definitely what it took to put a lot of this together, plus hopefully more shortly. Thank you so much. Appreciate it. Awesome. Yes.
Hey man, great app. I was gonna say how much is it? I want to buy the client because it looks so good. I mean, you said it's free, so.
That's right. Yeah, the application will always be open source. And when the email client is open source, the cloud infrastructure that we use to sync all the mail is also open source. Certainly, a lot of the like plugin systems we hope to charge for to keep it sustainable, but it's all there. Yeah.
I had one that was just a comment mostly. Technical question was, so I'm looking at shifting into the native application, and I was looking at React Native. What are your thoughts on that? And I don't know if that is, you can write Mac after that. But
Yeah, I'm very.
What was your experience with Electron?
Yeah, so the question was about like my thoughts on React Native, experience with Electron. I'm very optimistic about React Native on mobile devices. I've seen some very impressive things on there. Personally, wish I had more chance to play with them. My experience with Electron is so positive that I personally don't think that React OS X or React like Windows is necessary, like native like platforms like that. On the desktop, the Chrome is a extremely powerful not only rendering tool, layout engine, but also debugging system as well. I mean, when you think about how actually good the Chrome performance tools are, the stack tracer, the profiler, that's a lot for free that you get. And the other nice thing about Electron is it's only latest Chrome and only latest Node. So if it works there, you're done. And all of the annoyances of cross-platform, cross-browser compatibility things, we don't have to worry about. It's actually an extremely enjoyable ecosystem to develop on, and allows us to like build an app that can be even on multiple cores that we can make sure is running at 60 frames per second. There's definitely a lot in the Electron ecosystem that I would highly, highly recommend people check out. Yeah.
Clarify a little more what parts of your application are more appropriate to use actions in Redux as opposed to observables?
Yeah, the question was about where is it more appropriate for actions versus Redux versus observables. It generally came down the line, if anything was backed by the database, we tended to push towards observables. And that was really anything that was also sort of backed in the cloud, any of the core mail pieces. But a lot of smaller ad hoc things, like I said, like these component registries aren't necessarily backed in the cloud. Those tended to work a lot better with a more Redux-like system. The rule of thumb is how often, like what are the types of actions? If every action is very discrete, if it's like a easily nameable user action, then the Redux model tends to make a lot of sense. But if it's sort of constantly updating data, like in the case of this database, the observable system seems to have worked considerably better. Yeah, back there?
So you're using SQLite, you're using from query, you're using observables. This is something that's either pulling it or it's hitting it quite quickly to make these.
Yeah, from query is a little bit of a helper that we wrote. Luckily, SQLite will trigger on every change that it makes.
Well, my question is more about, like, are you loading SQLite in memory here? Like, if you have 100,000 emails, I'm guessing you're not going to be having that. So are you reading to the disk?
Yeah, we are. This is a nice thing we can do with Electron, just given, I mean, this is actually just stock Node in this case. But yeah, we compile SQLite. We use a Node SQLite library for it. We actually started off with like WebSQL and even looked at local storage. But when you're syncing several gigabytes of mail data locally, you want a real database. But yes, this means that actually we have pieces of our front-end code that need to be aware of indexes and call directly into this local database to pull the data. Yep. Yep.
Yeah, so if you're funneling the data constantly, do you ever get like a feedback loop where it triggers it and continues to build up, or like have like some critical thing where it just continues to build on itself?
The data set, not necessarily. I mean, certainly if you built a plugin that like on every data, like add some extra thing, you definitely get a lot of those loops. You do need to be careful about loops for things like anything that like renders and then requires you to like find the width and render it again. So yeah, there's definitely a couple gotchas about making sure that that you like listen to, that you put some checks and should component update and things like that. But in general, that's actually not a huge issue because these updates tend to be discrete and intentional. Yeah. Any final questions? Otherwise, I'll be around. Yeah, one more.
Do you have to combine observables at all? Have you done that?
Yes, we very frequently combine observables from both like multiple queries, from actually from some stores that we have and queries. Being able to combine observables is a hugely powerful piece. Actually, there is a great, this diagram shows, these are all these different ways you can combine these event streams. They actually get incredibly complex. But this is why I said one of the powers of this Rx library is if you do need to do some of these more sophisticated timing-based things, it is all here. Great. Thank you so much.